So my name is Nikhil. I'm a PM based in Seattle office at Google. And I'm here talking about Knative. So I have a demo towards the end, and it's a big demo. In the interest of time, I probably won't finish the demo. I'll just show the part of it. But I have the link here. So for those who want to follow, or maybe after the talk, the full demo actually is going to be on that link. So let me start with introducing what Knative is. I'll start with the definition of what Knative is and then dig down into the motivation of why we need something like Knative. So let's start with the definition, right? It's pretty obvious. It's a Kubernetes-based open source building blocks. It's basically serverless computing and container. So you basically merge serverless computing and container. And Kubernetes, is a platform for building platforms. So it's one layer. Actually, it's not technically one layer. There are multiple layers. I'll show the entire stack. But it's built on top of Kubernetes. So that's what Knative is. And we'll start with the basic of Kubernetes. I think there have been a lot of talks on Kubernetes, and I don't want to go too much into details. And kind of to use Knative, you don't really have to understand Kubernetes that much. I mean, that's the kind of point of having something like serverless, is that developers get abstracted from the operational complexity beneath. But yeah, Kubernetes is like kind of a de facto platform for orchestration, something like Docker Swarm or Mesosphere. It handles container. It's basically a way of you describing your resources in a descriptive way, and then the system tries to bring that actual state as close as possible to what you describe. And Kubernetes basically does a lot of things for you. It deals with all sorts of things like scheduling, check, load balancing, etc., etc. You have a full list and probably a lot more than that. But that's not a good platform for developers. So in the Kubernetes world, we basically have two categories of users. We have the developers, and then we have the operators, right? Operators are the one that deals with all the abstractions that deals with the underlying infrastructure, and they kind of worry about Kubernetes and how to maintain the cluster. And then we have the developers who ideally do not want to get their hands dirty in the operational complexity, and they just focus on their code. So these are the two set of users for Kubernetes. And Kubernetes ecosystem, it's a big ecosystem. A lot of companies use it. I probably wouldn't be exaggerating by saying it's kind of the most popular container orchestration system out there. Very popular. You hear a lot in just about every conference. So yeah, so these are the two different, this is like the kind of, now I'll just step back and I'll start with the motivation of serverless. Now I mentioned that there were two set of users, right? The operators and the developers. And this is the kind of model for operators. Operators, they don't want to do any infra management. They want the managed security, and kind of the serverless says that you only pay for what you use. So that's how the operators want to, this is like the operator's view of the serverless. Then comes the developers, or the programming model, right? It's a service-based, so you have these, it's functions and services we kind of interchange, because in serverless, if you use something like AWS Lambda, they will call that as functions. But I would say function and service, for the context of this talk at least, is kind of the same. It's an event-driven, so you fire off an event, the system reacts. And last thing, it's portable. Now, this is kind of portable from the Knative point of view. It's not serverless in general is not portable. For example, if you use AWS Lambda or Azure Functions, you're tying very much into the underlying platform, and that's actually one of the drawbacks of using something like serverless, is that you obviously get shielded from the operational complexity of it, but you're also doing a lot of like vendor dependence, right? Sometimes the good thing about Knative and anything built on Kubernetes is kind of the de facto platform which is available on on AWS, Azure, at your own local data center, whatever, and anything built on top of it, you obviously tie it down to Kubernetes, but because Kubernetes is widespread available, it's kind of portable. So in the sense that I have a local cluster on my data center and I want to move my workload from there to Azure. Azure has Azure Kubernetes service. I can move it. Then I can move it to Google on top of Google Kubernetes service. So that's why for something like Knative or anything built on top of Kubernetes, it's actually kind of portable. So now we come back to containers, right? Containers is kind of quite popular way of deploying your code. It's a mini virtual machine, kind of. There are a lot of these containers. It's huge base image you build on top of it. Supports multiple languages, supports even binary. In fact, one of the demo I have actually shows how to install a binary, which is something that you can't do on a system like AWS Lambda. I don't know if I'll have time to get to that point, but if I do, I'll point this out. But you can basically install binary here also. So that's containers. And it's kind of an industry standard, right? If you look at the trends, increasingly it's being adopted, and it's actually a very popular way of deploying your microservices. So coming back to Knative, what Knative basically brings, it marries the two things. So it brings that serverless model to the containers. So now what you have is you have these functions or services, I'll use the term interchangeably, deployed on a container, and you have essentially a serverless model applied to those containers. So there are these common building blocks like serving, eventing, and build. I've actually crossed out build because the earlier versions of Knative supported all three of them. And then they decided to deprecate build before 0.9 version and replace it with Tecton. So actually there was a talk about Tecton pipelines in the morning. I'm not going to repeat it. I have a slide on this just to give you a brief intro to what Tecton is. Tecton itself is a big topic, right? You could talk for it for an hour. But anyway, so it has these common ingredients that you would use on a serverless workloads, and it's basically designed for modern development partners. So Google kind of started it, and then it's open source, and now Pivotal and Red Hat and IBM and SAP are mainly partners. So we have like a weekly sync between all, and there were plans to give it to Cloud Native Foundation. But that didn't happen. Apparently, a lot of people got upset with it, and there was this back and forth debate. But again, that's the politics of the issue I won't get into. But yeah, but it's fully open source. And that's good because open source, what you could do is you can use it on multiple platforms. In fact, I'll cover this later on, but a lot of, one of the uses of something like Knative is that you can have a hybrid scenario, because you can have some services running on AWS, some services running on GCP, and some on local, and they all can seamlessly talk to each other. And not only can they talk to each other, you can move the workloads across different cloud versions or your own private data center. So I'll cover that aspect also a little bit, and I have a demo about it, again, subject to how much time I'll have at the end. So what's the motivation for Knative? Well, the developers want serverless, right? They just want to focus on their code. They don't want to deal with underlying infrastructure. And developers, people have different programming languages, preferences, different ways of doing it, etc. Something like containers, basically, because of the huge variety of base image that you have, gives developers the flexibility to implement their services any way they want. So that's the developer side of the story. The operator side of the story is, operators don't want to manage the infrastructure that much. Developers don't want it also. They want to have something like Kubernetes, which is a great orchestration system, and they love using all sorts of Kubernetes, GKE, Google Kubernetes, which is the Google version of Kubernetes. Kubernetes is obviously not the right abstraction for developers, but it's definitely the right abstraction for operators. So that's the two sides of the story, right? The developers and the operators. And Knative for developer, what Knative gives you all the common components, so you can write your own code. You don't have to worry about building the Docker image. You don't have to worry about all the handling of how to upload it in registry, expose it, setup logging, etc. In fact, I'll show the Knative stack in details, and it actually has Istio as one of the layers. So it's logging, monitoring, traffic routing, all this is handled by Istio, although you can swap it out for something else if you want. But anyway. And obviously, you have automatic scaling also, which is what the serving component will do, which I'll also talk about. So that's the developer view of Knative. Talking about the operator view of Knative, right? It Kubernetes kind of abstracts out the operational complexity. And like I mentioned before, it's kind of universally supported by major cloud vendors. And it's quite extendable. In fact, Kubernetes is basically a platform for building platforms. The quote is that it's never an end goal, but it's actually a great place to start. And then you have several platforms like Knative built on top of Kubernetes. And then you have several platforms built on top of Knative also. Some of them are open source, some of them are commercial. I'll just show a stack. I think it's probably, it would be one of the slides later on. But here's a confusion about Knative. Because Knative, there are two things about Knative. Knative is a product, but Knative also is a reference API. So there are implementations, I wouldn't call them Knative implementations, but there are implementations that follow the reference API, but they are different from Knative. What's the advantage of having such implemented? The advantage is that if you want to move your workload to those products or bring it back to Knative, because the API is the same, you actually can move around the workload without modifying your code. In fact, there are two products by Google, Cloudrun and Cloudrun on GKE, and I have a slide on both of them. That actually, implementation-wise, they are different from Knative, but they follow the same reference API. So what that would mean is you can have Knative on your private data center, and you can have service on Cloudrun running. They use the same API, and you can move seamlessly, right? So you can have a hybrid cloud kind of scenario. So Knative could mean the reference API, Knative could mean a specific implementation. It's kind of confusing. And it's built on top of Kubernetes. So anywhere where there's Kubernetes, which is practically everywhere, you can have Knative installed on top of it. In the demo, I'm actually going to do that. I'm going to create a cluster on GKE, install Knative, and show how it auto-scales on the services. So this is the stack, right? Underneath you have Kubernetes. And then you have the service mesh. Istio is the default one. It's by far the most popular ones. There are Glue and Ambassadors. I haven't really come across a lot of people who have used anything except Istio. And honestly, I don't really know why you would kind of want to do that. But nevertheless, you do have a choice for whatever reason. And then you have the primitives, right? You have the primitives for Knative, which is serving, which is how your traffic is routed, and events. Because the services or the functions on Knative are event-based, you need a way to consume those events. So eventing kind of gives you that structure. I'll explain both serving and eventing. And then you had build, which is now deprecated and replaced by Tecton. That is why I've graded out. And then you have several commercial products built on top of that. So like I said, it's a layered stack. If I have time, I'll show Google Cloud Run and Google Cloud Run GKE, and I can show how to do a hybrid cloud. And then there is SAP, and I think the Red Hat also has, there's a product called Riff from Pivotal. There are multiple products built on top of it, but that's the Knative stack. So yeah, so on Google Cloud particularly, there are 3 different products. Cloudrun on GKE, it's actually being now commercially renamed as Cloudrun for Anthos. Cloudrun was a beta product, but it's actually going to be a GA soon, quite soon actually. And then you have the Knative. And mind you, the reference API is the same. So while they may be different implementations underneath, to a developer, they would be the same. And that is the reason why you can move the workload seamlessly. I'll briefly touch upon Cloudrun and Cloudrun GKE and show a demo for it. But for now, let me focus on Knative. So let's start with the components. So Knative serving. What is Knative serving? Knative serving is essentially deployment of containers, right? And it gives you an automated scaling from 0 to n. There were feature requests that sometimes people want 1 or 2 warm instances already, because cold start can often be a problem. So there are some workarounds, and there is some work to do that. But for now, you have an automated scaling from 0 to n. So if you're not using it, scales down to 0. And you have these immutable configurations. And every time you deploy a new container with the same name, you actually create a new revision. And in the demo, I'll actually show how to create a new revision, and then I can also have something like traffic splitting, sometimes for A/B test or whatever. You want to say 50% of the traffic would go to one revision, 50% of traffic would go to another revision, or anything like that. And you can use the built-in logging or monitoring, or you can have your own component. You can also, being open source and being very flexible, you can also have your own auto-scaler. There was a debate that happened in Knative community, and what happened was that Knative initially was one product in one repository. And then they deliberately separated out into components. And the reason why, and I can actually show the website, the reason why they wanted to separate was they don't want to have Knative as a single product, but they want to portray Knative as set of multiple components, so that gives the developer the flexibility that you can swap one component for another one. In fact, you can even, in theory, of course, you might run into compatibility issues, have an eventing version 8 working with build version 7, working with, I don't know, serving version 5, for example, right? So you have these different components, so you can mix and match any way you want, and you can plug them out. So it's a very flexible system, how you want to do it. So you have, at higher level, you have the service or the function or container. You have a configuration. I'll show some examples so it will become more clear. You have some, in my demo, I have some environment variables. You create these revisions, point-in-time snapshots, and then you route the traffic. And by default, the traffic would go to the latest revision, but you can split it also in any way you want. So that's how the serving works. Let's talk about eventing. We are talking about an event-based system, so we obviously need a way to produce and consume events. So what is it? It's basically a Knative-based systems are loosely coupled event-driven services, right? So you declaratively bind the events, produces, and services, and there are all these different event types, and there are all these ways of how to consume that event, right? You can have like events for GCP, you can have event for Kubernetes, all sorts of different ways on how you can actually capture these events. So there's a source, there's a producer, there's a trigger, which is typically what you expect from an event-driven system. Again, depending on time, I might be able to cover eventing. And you have a lot of different event sources here. So I have Apache, Kafka, very common, Google Cloud, being kind of having its origins in Google, you would expect good ways of consuming Google events. So you have all of that, and then you can have different examples of use cases. For example, cron jobs and process IoT and so on. Although if you're typically on GCP, there are other ways of doing it. Also, they have like cloud task and other ways of doing it, but nevertheless, Knative provides you one. And there are a lot of samples. If you go to this website, GitHub, I'll actually walk through the Knative website and Knative GitHub repository. But there are a lot of samples on how you can collect and consume events. So let's talk about building, right? This was the original build, which was before 0.8, and then it got replaced by Tekton pipelines. Post 8, again, I'm not going to cover details of either one of them. Tekton, we had a talk in the morning, and build is kind of deprecated, so no point going into details. But for the sake of completion, it's essentially how your source code goes to the container images on repository. That's what build is going to be, and there are different templates and service accounts, how to deal with all sorts of things like Docker registry, authentication, etc. But like I said, it's actually a deprecated component replaced by Tekton pipelines. Tekton is actually quite, you have the GitHub link, they're quite broad projects. In fact, I know Google had some collaboration with Jenkins Cloud Bees. I was actually in Jenkins World a month back, and they were talking a lot on Tekton. A lot of Jenkins X actually is based on Tekton. We had some Google engineers working with Jenkins, because internally we have systems which are internal, they are not public, and kind of Jenkins X borrows a lot from there. So we had a very close collaboration, but nevertheless, Tekton is like basically a modern CI/CD platform based on Kubernetes. Like the thing with Kubernetes is basically a platform for platform, and what you see is people building layers and layers on top of Kubernetes, right? So we had the whole serverless on Knative, and now you have a CI/CD system, because one of the complaints you have is, let's say I use something like a classic Jenkins, and I have my build agents, and whether I'm building or not, I have like say 100 agents, they're always there. I'm paying for them even if I'm not using. The benefit of something like Kubernetes is that if you're not building, you can scale down those agents to 0, right? Because Kubernetes allows you to do that. So Tekton kind of, the motivation comes from there, and then of course all the Kubernetes way of declaring the CI/CD pipeline. So that's what Tekton project is, and that's the website for it. So Knative, it's a very active community. I'll walk through the website. We always welcome contributions. Feedback is always appreciated. So that's the value for Knative: auto scale, one-step deploy, manage workloads. And I think at this point I was probably gonna pause. And what I'm going to do is I'm going to switch to demo. Okay, so let me actually first go to knative.dev. Okay, so that's the Knative website. Some of the things are in, okay, good. So it talks about what Knative is, and I think somewhere here you would have view repository. So let's go into Knative repository. And in this repository, you have, that's the, okay, actually some of the components I should probably lock out because some of the components are not for public, so it will show you all the stuff. That's the problem when you work for Google, that there's a lot of proprietary stuff. Anyway, so you see the eventing and serving, and these are like separate resources. Test infra and all that is basically internal for us when we deploy it. But we always welcome contributions, and then you have the docs website. But docs is now moved to the main website, Knative, so you will have documentation here. So that's the Knative. Now what I am going to do is I'm actually going to go to my demo. So the first demo I have is I basically would install, so that's the demo. That's a full demo. It has the link to the slides of how you install eventing, translation, API, something. We probably won't cover all of it. I'll just cover probably the serving part of it. And then I'll move to Cloudrun, and I'll try to show how to create a hybrid with Knative and Cloudrun. I have 27 minutes remaining, so I have good enough time for now. Okay. So I'll just take some shortcuts here in the interest of time. So I would, right. We create a cluster. Good. Zone, Europe-West, just for fast. And now I'm actually going to create, oh sorry. Why is it I need to do a copy paste? Okay. If I run this command, it actually will create a cluster, but I am just not going to run it for too long. I'll just start because it takes a while and I don't want to waste time here. So I'm going to create a different cluster name. I'm just going to call it Knative 2. It would start creating a cluster. Okay, cloud.google.com. Console, it logs me in. Okay, so now I go to my clusters on GKE. Where is it? Sorry, I must have, okay, Kubernetes clusters. So I am trying to create a new cluster Knative 2, but I in the morning build one Knative 1 for the demo purpose. So it takes a while, so I'm going to kill this and I'm just going to use the cluster that I already have, just in the interest of time. Okay, so it's building the cluster. It would have built the cluster. Okay, so now that we have the cluster, I would grant some permission, admin role to the current user, It actually should already be done because I think already exists because I set it up in the morning. I just tested my demo before the presentation. But yeah, in case you don't, you need to grant the permission. And then what I'm going to do is I'm going to install Knative. Okay, so these are all, these instructions are all, if you go to the demo, you would actually see. So I'm basically running these commands, right? I'm installing Knative. So again, I've already done that on my cluster, so I might just get an error or something. It's already done, but let's see what happens. Okay, it basically will install it. It'll install a new copy. Great. So now my, okay, so I've done the serving YAML. Okay, I think I'm, okay. Yeah, so I need this, okay, so I'm now setting up my cluster again. I'm actually kind of redoing it, but sure. So now my cluster has Knative installed on it. Just to make sure everything is working, I should have pods with serving. So pods are running with serving, which is good. It means serving is working fine. I'll check my pods for eventing. Eventing is fine. Monitoring is fine. Good. Then I have, let me actually show you what I have here. I have the hello world. So I have examples in Python and C, but I'm just gonna use Python as an example. It's probably more popular. So simple hello world, I just read an environment variable, and this is something in my example that I'm using it as a config. So that's why I have this, and just say hello, whatever your target variable is. So let's go back, and I'm gcloud build. So I'm actually using the Google Cloud build to build my container in the cloud, but you could actually do it on your local machine or a Docker build also. It kind of works the same thing. So now it builds a new hello world, and on my container registry, which is going to be here, where is it? Container registry images. Most of it I've already pre-built, but you should see one. Okay, this was one I built 3 hours ago. I'm going to build one right now. It's building, it's pushing, and in a minute or so I should see the new one. Good. So now I go back and I see a one that I built just now. So that's the one I built just now. It's a simple hello world. That's basically the Python code. I'm using Python Flask as my framework, which is probably the easiest thing you could do. And then I basically have serving YAML. So this is my serving YAML, right? API version. My first container, I'm actually going to tag it with hello world version 1. And in my configuration, I basically have my container registry, and I have an environment variable target v1. So that's basically my YAML file that I'm now going to, I don't need this right now, that I'm actually going to deploy the service. Okay, so let me go down and let me deploy the service. Configured, wonderful. We want to test what's happening. So everything looks good, and it will assign you an IP address. So we can go and look at it, kubectl, istio, gateway, and you see that IP address here. This is the external IP, and what I'm actually going to do is, because I'm going to ping the service multiple times, I just want to assign this. So now I can say echo external IP. Okay, I have it in my environment variable. I am going to make sure the pods are working initially. That's good, running, restart. Check everything works. So now I'm actually going to, and this is my version 1, so I should see something like hello world version 1. It might take time because of the cold start, but I get the version 1. So yeah, so that's where I get the version 1 of this one. Good. Now I'm going to create a second version, and this one will pretty much be the same. My container still stays the same, but I'm just going to change the config. So what I have now is I have an environment variable here with v2, right? So as usual, I would apply this to v2 here, and good. So it's v2. Now when I ping, let me repeat, I should see v2 here. Come on. Oh, good, v2. So I had first configuration v1, then I created second configuration v2, and the way traffic routes is every time you deploy a new configuration, 100% of the traffic would go to your latest configuration, unless you decide to change that or split the traffic, which is what I'm going to do now. So now I have a third YAML, and what I'm going to do is everything stays the same. I'm just going to call it hello v1, but I am going to split the traffic here. So I have two revisions, v1 and v2. I can say 30, 50, or actually I can do anything I want. I can just say 30, 70, right? Let's say 30, 70 instead of 50, 50. And now I am going to apply this. So it says applied your new configuration. Wonderful. The next thing I'm going to do is I've applied the new ones. I will, first of all, let me do the simple curl. See what happens. It should give you either v1 or v2 with a probability that it's 30 or 70. v2, it's always giving v2, weird. Actually, what was my probability? It was 70% of v2 and 30% v1. Yeah, so it works. So sometimes you're getting v2 or sometimes you're getting v1. Statistically, 70% of the time you would get v2 and 30% of the time you would get v1, which is kind of something what we are getting. Maybe you're getting too much of v2. I can change the configuration, and what I'm going to do is I'm going to do the opposite. I'm going to say 10% of 90% of the time I'm going to get v1, and 90% of the time I'm going to get v2. And now I reapply this configuration. Sorry. Oh yeah, since I pinged it multiple times, I reapply this configuration. And now I should predominantly get v1, not v2. Yeah, predominantly mine. So this is an example of how I created multiple versions, and then I can split the traffic. Right now, so here's what I'm going to do. I'm going to do some funky stuff here. I am going to get pods. Okay, let's see what happens. So I actually had three versions, right? v1, v2, and v3. That is why you see 3 pods. In fact, if I wait a little bit, I would actually see 0. And the reason why I will see 0 after waiting a little bit is because it's an auto scaler. If you don't get any request, it scales down to 0. So if I don't ping it anymore, after a while, you won't see any pods because everything goes down to 0. So that's an example of serving. What I'm going to now switch back to is I would show an example of the managed service or Cloudrun, which uses Knative API. But anyway, so let me go to another GitHub page I have, and I have a Cloudrun demo here somewhere. The internet has been flaky, but okay, that's my fork. Okay, Cloudrun demo. And there's something very interesting about this demo. And the reason why it's interesting, it's something you cannot actually do it on Google Cloud Functions, Azure Functions, or AWS Lambda. And the reason why you can't do it is what this does is it lets you create a MS-DOC file and will convert it to PDF. And it doesn't use it uses OpenOffice, which is a binary, right? So you install OpenOffice on your container, and then you would build it and use it. And you can't do that on AWS Lambda, because in AWS Lambda, you don't really have the facility of using a binary. You have to put the source code and compile it. But with containers, like I mentioned, you can have your own source code. You can install binaries. You can actually do that. So there was this cool new feature you can press and it'll directly deploy to Google Cloudrun. Somebody built it. It's actually pretty funny, but I'm not going to use it right now because I want to show the manual steps of what happens. I don't even have this repo cloned actually, so first I should. Oh, sorry. Okay. So, Cloudrun cloning. I'm going to open up another. I have 14 minutes remaining. I have a good amount of time. Desktop, and let me actually open up Cloudrun. Okay. So now I have my Docker file here. And you can look at the Docker file. I use Python Alpine. I still use the same Flask framework. But what I do is I use the OpenOffice. And these are all the MS fonts and everything you actually would have to use with this. So I have all of that in my Docker file. And I have this Python to PDF. And what this Python file does is, this is the standard Flask stuff you can call LibreOffice. But this is the part that is important. So you basically call LibreOffice convert to PDF. You give it the input-output file. And okay, now that I have done this, I go to my Cloudrun. I built it. What I'm going to do is I'm actually going to wait a minute. Again, in the interest of time, I'm actually not going to build the container. I'll just start and then stop. And the reason why I don't want to build that container is it takes a lot of time. And the reason is you're actually installing OpenOffice in a container, which is a big binary. So all my time will go away. So I actually have pre-built containers that I did a demo a long time back. But yeah, so I basically would use my same thing. I would use something like, I go here. I obviously will not use Cloudrun Demo, PDF service. I can create a container like that. And no. Gcloud builds submit. Don't really need tag gcr.io/ and Barthwal Cloudrun etc. Cloudrun Demo / PDF service v1, and I press and it builds, starts the build process. Takes a lot of time, but I have these images built in here. So when I go to my container registry, I go back, I would see my Cloudrun demo, which I built a while back, a month back. It wasn't scanned, but it's okay. So now, what I'm going to do here is, okay, I'm going to deploy it to my Cloudrun, which is the managed Knative hosting. So I go to Cloudrun. Okay, Cloudrun. I did not explain the Cloudrun and Cloudrun on GKE concept. So there are two versions of Cloudrun. You have a fully managed one, and then you have one which is built on top of GKE. And this is a very common question of why would you have two different products. It's kind of confusing to the people. The reason is some people don't like to manage any infrastructure, and Cloudrun, or I should specifically say Cloudrun on fully managed, actually enables you to do that. It manages everything, but when it manages everything, it does not give you the ability to go in the underneath cluster and inspect, because it's actually doing all that stuff for you. In fact, it's actually not even built in Kubernetes, it's actually built in Borg, which is like the Google's version of Kubernetes, from where Kubernetes is an open source community version of what Google had internally called Borg. So it actually runs on Borg, it doesn't even run on Kubernetes. And for some people, that's a problem because they need to have access to the underlying infrastructure. And sometimes they're using GKE, sometimes they have their own Kubernetes, and they don't want to use a product which is completely managed. They want to have access. So they would run Cloudrun on GKE. So let's go back, and that's the managed platform. I can just say create service. Ready? I can say create service. It says select me the container URL. I already have one build, which was on August 14, so it was built a while back. And I have two choices. I have Cloudrun or Cloudrun on Nantes, which is the commercial name of Cloudrun for GKE. So when I do Cloudrun, I basically selected US Central, or I can do Cloudrun for Nantes. And here I need to have my own cluster. So I have a standard cluster that I built, which I can show you here. When you go to Kubernetes cluster, you basically create a cluster. You create a new cluster, but when you create a new cluster and you want to use Knative, make sure to enable Knative. And the way you enable Knative is you go into advanced options, which is somewhere here, more options, availability and additional feature. And you will see down there, enable Cloudrun, which right now is, where is it? It's somewhere down. You would see you want to enable Cloudrun. I can't seem to find it. Okay, maybe it's not displaying because enable Cloud TPU, enable Cloudrun. Where is that option? Okay, it's here somewhere. Private cluster, enable Google RBACs. Okay, I don't know where it's messing. Anyway, it's here somewhere. I think I need to, no, it's zonal is fine, cloud cluster. I need to do that, add node pool, enable Istio. There you go. When I enable Istio, I have this option which right now will not work because stack driver, legacy mode and something is enabled. So you have to work through, to disable the legacy mode here. I disable the legacy mode. This gets enabled, and then I have to basically click and it says enable Cloudrun. So now you can use it, but again, it's pretty straightforward. I don't have that much of time to show, so I'll come back quickly to where I was. I go back to Cloudrun, and now I'm going to create a service, and I select my image that I had for this demo build, and I say US Central 1, and I just call the service name. There are two options. I can have managed required authentication, so I can use Google Cloud IAM, or I can just say now create. And it's creating, and it's going to quickly deploy, and it's going to get deployed, and it has service account and all those things. Meanwhile, what I'm going to do is I'm going to say, what do I say? Nantes is DevFest rocks. Okay, and I will just put this in a big font so everybody sees it. Build it like that. 36 is a good size. And then I save this file. I save this file. I can save it on my desktop, demo. Actually, I should save it as my MS Word file. So it says export to Word. Okay, export to Word demo. Okay, I think I misspelled it, but never mind. Yeah, so it creates this supposedly MS Word file. I have my MS Word is not activated right now, but I can use Pages to open it anyway. I have this. Okay, so this is good. Now I go back, the service is deployed, and that's the URL. And because I selected unauthenticated, I can actually click here, and it'll take me to URL. It's going to take time to start the first time because the cold start, because it's the first time, and I say, okay, I take this demo. So this is what's going to do is it has installed OpenOffice. It would take the doc file and it will convert to PDF. And I say upload. Okay, so it's going to upload, it's processing, and Then I'm a little bit running out of time. So while it's processing, I want to show something. The YAML. So like I mentioned, the API is the same for Cloudrun and Cloudrun on YAML. So it has basically created a PDF file for me. This is the PDF file. I'm just going to save it here and I can open it and download. So that's the download.pdf that I see here. Right, whatever I typed in my MS Word file, it goes. And then the interesting part that I want to show, which ties it back to Knative, is this. So the YAML that you see here, this is Knative YAML. So Cloudrun as a product and Knative uses the same API, and this here is the API difference. So if I have it on Knative, I don't have time to show it to, but if I had all this in Knative, I can just cut and paste this YAML and just kubectl and apply. It will basically do identical to what Knative did. So that's the Knative YAML, and what that allows me to do is I can take this service, which is right now deployed on Cloudrun, and apply it same to my local Kubernetes cluster, basically on Knative, and vice versa. And if I have to do that, that's the YAML I have. And I can then essentially have a hybrid service where I have certain workloads running on Kubernetes local Knative and certain on Cloudrun and certain probably on Cloudrun GKE. And I can do the same for Azure, and I can all make them work with each other and move the workloads as it is in a hybrid cloud scenario. Okay, so with this, I'm almost at the end. So I have some links. That's the Knative website, that's the Slack channel, and that's my Twitter handle. If you have any questions, I'm happy to take it right now. I have about 3 minutes remaining.